Hello, everyone. My name is Arsalan Khan. I am the Director of Technical Marketing at Graphiant. For the demo, what we are going to go through is how can we leverage the gateway service and its private connectivity to our core, as well as its private connectivity into the different public clouds to be able to use their Jumbo Frame offering. There are two cloud providers at the moment that offer Jumbo Frame. So you have AWS, you have OCI, and then there are various restrictions on what's possible. For example, in AWS, you cannot do it across regions. As long as it's within a region, they do support Jumbo Frames. So again, when we think about the requirements for enterprise workloads, you have many different clouds, you have on-premises locations, you need to be able to connect all of these together. If you look at the Oracle cloud infrastructure, so Oracle's been in the database game for a very, 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 very long time. And there are a lot of customers who still use Oracle databases. In that case, you may have a limitation of, does my application have to run in the Oracle cloud? Or is there a way for me to be able to run my application somewhere else, have my database running in OCI? Now, being able to improve that is, can I use Jumbo Frames to avoid having to break packets down while sending them over the network? And if it's mainly about some cloud workload connecting into Oracle, what is a possible way for me to be able to do that? Using our solution, so using AWS's Jumbo Frame support, using Oracle Jumbo Frame support, we'll go through how that's possible. We'll take a quick look at what the topology looks like. So you have a deployment in AWS on the left. You have a deployment in Oracle at the bottom. Then we have a data center, which is up top. And then we have a branch that's all the way on the right. The key thing here is AWS, Oracle, and the data center are all privately connected to the Graphiant stateless core, which means we do not have MTU restrictions. The edge, on the other hand, sits outside. In that case, it's not over a private connection, so it just goes over the internet. So this is in the portal where we have all of these different devices that I talked about. So we have the AWS gateway in the Graphiant environment, we have the OCI gateway, we have the branch, and we have the data center connection. If we choose the OCI branch, the OCI location, this is the interface where you can see this segment that is Jumbo Frames. This is the connection that we have into our environment. So what you can see here is the MTU is set to 9,000, and the speed that we have is a gigabit per second connection.
Is that detected, like how did it determine that it was a gigabit connection? Did we set that, or did it?
It automatically detects it based on the port speed.
Gotcha, okay.
Now, this is the OCI device. So we'll go to routing and take a look at the routes in that Jumbo Frame LAN segment. Now, in this segment, what you'll see are 5 different routes that we're learning. You can see that the top 2 are local routes. This means this is what's coming from OCI and is advertised into the rest of the network. And what you'll see at the bottom are those 3 are being learned from the different devices on the network. So it shows you that there is one route being learned from the edge, one being learned from the data center, and the one at the bottom is the one being learned from AWS. Going through these routes, then we go in and take a look at the AWS device. So now we simply navigated away from the OCI device to go check on the other end. Am I also learning the routes coming from the OCI gateway? We go through the same process. We go take a look at the routes being learned here. We expect to see 5 routes as well. 1 that's being advertised from here, and 4 others that we're learning. We're learning 2 from Oracle. We're learning 1 from the data center. We're learning 1 from the branch. Bringing all of that together, so now we know that at least from a routing point of view, we have routes being advertised from both of these locations to each other, as well as being able to learn routes from the data center and the branch. This is one of the devices running in AWS. So using the AWS console, we're going to be able to try and send traffic from here over to the Oracle environment. Here, we're going to set the size of the packet. We're going to use 8192 to make sure that we're able to send a bigger packet that gets received on the other end. So, hey, it works. It was a recording, so I knew it would work, and I'm still excited. Now we do the same thing. We're going to go through, we're going to run the ping to check it with the data center. So in this case, almost as a, just a sneak peek into if a data center is connected over a private connection to us, it is possible for you to be able to run those jumbo frames, even from a data center all the way to the cloud. So that's something that gets covered as part of this as well. And then we simply run the same kind of test. We're running it from the Oracle side over to AWS. We run the same thing from the data center to Oracle, just making sure it all behaves the same way across the board. Now, if I forward ahead a little bit, so the next thing we did was we're simply running an iPerf test to be able to see what kind of performance are we getting. This is with the bigger packets, so we expect it to be better than what you would expect otherwise if you were fragmenting. In this case, we're getting about 950 megabits per second over a 1 gig link. Now we run through the exact same test with a smaller packet size. What you will notice is the difference in this case is mainly just the header difference. Because we're sending 10 times less headers, we're saving about 100 megabits per second here. So instead of 850 that happens with smaller packet size, we get 950. This is mainly because everything is fairly closely located. If you were to do this over a longer distance with higher latency using TCP, you would see much different numbers. And that's where multiple regions, multiple clouds, that starts to factor into it.
I think for the benefit of audience and some of us, how do you handle the labels between the B2B connectivity scenario?
Can you
How do
elaborate a
you
bit?
handle the Graphiant label for a B2B scenario?
Mm-hmm.
Because the Graphiant label is unique for customer, like it has the customer identifier or something.
So the segments that get created, a segment doesn't have to be tied to an enterprise. You will have your own enterprise segment, but in a case where you need to deal with B2B, there is a third segment that gets created, which is these two enterprises, specifically with these devices, can use this segment. And because it's a multi-tenant environment, you create a third segment in the same environment, and then you can have different enterprises use that.
Well, who creates that?
That's all done as part of Graphiant service. When you sign up for B2B, it will automatically get created, and there is no configuration or provisioning or Python automation that we go ahead and do. Natively, the protocols support it the way we've set it up.